Okay, in numbers 10 and 11, we're asked, without using graphing technology, to sketch the graph of each polynomial function using the information provided. So we've got verbal descriptions, and we're going to write the equation and then sketch the graph. So a polynomial with a leading coefficient that's negative, right? So y equals a negative leading coefficient, and zeros of x equals -2 with multiplicity of 2. So that would correspond to a factor of x plus 2, and since it's a double root, it's going to have an exponent of 2. And then x equals +1 would be a factor of x minus 1, and since it doesn't say there's any multiplicity, it's not a repeated root, that just is a linear factor and the exponent just stays a 1. So now when I go to sketch this polynomial, I can start by considering my end behavior. Since the degree here is 3, that's an odd degree and a negative leading coefficient. And we know the end behavior for odd degree with a negative leading coefficient is going to start up and end down, right? So up on the left end and down on the right end. Okay, that's important because when I go to sketch my bounce here at -2, I need to know the end behavior ahead of time so I know whether I'm opening this bounce upward or downward, right? So my other zero here is at +1, and that has a linear factor, so it's going to cross, and again I need to know that end behavior ahead of time because otherwise I don't know if it crosses up and with a positive slope or if it's going to cross down with a negative slope until I know that end behavior. So now that I see my ends here and my zeros, I know I have to start up on the left, so this bounce has to face up. Right, it's going to bounce this direction. And then it has to end on the right going down toward -infinity. So this cross at this linear factor has to head down like this. So when I connect that, remembering that a polynomial is a smooth continuous curve, right, I can join these up like this, and there would be a polynomial that has a negative leading coefficient, zeros of x equals -2 with multiplicity of 2, and x equals +1. Okay. There is no scale here on the y-axis, right, because we're only concerned with the general shape of the function and not worried about finding exact ordered pairs, right? We're just making a rough sketch. So now in number 11, I want to create a polynomial with a positive leading coefficient, and then its zeros are x equals -2 with multiplicity 3. So my factor would be x plus 2, and then the exponent is a 3. Okay, then x equals 0 has no multiplicity listed, so that's going to be a cross, right? That's just a linear factor, and since it's just an x, to get x equals 0, I'm going to put that in the front. And then x equals 3 has multiplicity of 2, so that factor corresponding to the 0 x equals 3 is x minus 3, and it has multiplicity 2, so that's going to cause a bounce with that exponent of 2. Okay, the leading coefficient is positive, so y equals, and this would be the equation that will produce this graph. Okay, when I look at my degree, I have 1 plus 3 is 4 plus 2 is 6, and so this is even degree with a positive leading coefficient, and that tells me that my end behavior will start up and end up, right? Both ends will face up for even degree polynomials with a positive leading coefficient. So now at x equals 0, I have a real 0. At x equals -2, there's another real 0. At x equals +3, There's another real 0. And then I can use the multiplicity to decide, is it going to bounce, wiggle, or cross through those zeros. So the x minus 3 has multiplicity of 2. That's going to be a bounce then here. And since the function has to end facing up on the right, that bounce needs to open upward, right? So that my end is going to end facing up. Okay, then my wiggle here at x plus 2 to the third power, that wiggle has to join up with this end that's pointing up on the left. And that means I can't wiggle this way through the 0, right? Because then it wouldn't join up. So I have to start up and then head down with my wiggle here through x equals -2, because this end has to face up on the left. Then that means my cross for this factor of x equals 0, my cross has to start down, so it hooks up here, and it has to end facing up so that it hooks up over here. So the cross is going to face this direction. So there's my bounce, my wiggle, and my cross, and I'm going to make a smooth curve because it's a polynomial, so no sharp, jagged turns. And that means that this curve needs to come down here and then gently bend to hook up here, and then again have a gentle bend so that it stays a smooth, continuous curve. And then my ends head up to positive infinity on both the left and the right.